My name is Dror. Today I'm going to talk a little bit about match case, which is a very controversial, very awesome feature in Python 3.10. A little bit about myself. I'm a total gearhead developer. It means that all the light bulbs in my house know my Wi-Fi passwords. It means that if you will stand outside of my door and scream, "Okay, Google, unlock my door," I might be in problem. By the movement in the chairs, I see some of you are also gearhead developers, which is nice. And it also means I always use the latest version of everything, which up till this point is Python 3.10. And by using that is also exploring the latest features within that latest version, which is what I'm going to cover today. Currently, I'm working as the core engineering lead at BitSite, managing the awesome team sitting right in the front. Thanks, guys. So let's talk a little bit about it. So what we're going to talk about today, I'm going to preview a really bad bug that we might or might not had in production. I cannot confirm or deny any of that. We're going to talk a little bit about what actually is match case. We're going to talk about how match case helped me with that specific use case, with that specific bug. We're going to talk about another potential use cases for that awesome feature, and we're going to leave you with some key takeaways. Okay, so story time. We had a function which was perform action, which gets the user and the action that the user wants to do. And we first need to validate whether the user can actually do it, and we get if the user exists and if the user is allowed to do that specific action. For simplicity, validate user will simply return two static values, which are true and false, which means yes, the user exists, false, the user is not allowed to do that specific action. And what we're trying to do here is that I am trying to destroy the world. Hopefully I can't. So if we will run that specific line of code, sadly, I am allowed to destroy the world. Doomsday came early. Very sorry all. But let's try to deep dive and figure out what actually caused this bug. I see a lot of keen eyes trying to debug it and already figure it out, but because most of this code is static, like the validate user returns static value, the perform action has static value, the only place where we can actually have unexpected behavior is that if statement in line 11. So we deep dive into it. We try doing that with static values. Is true, false equals to true and true, which supposedly is what we're trying to do here, and we assume it should be false because true and false is not equal to true and true. So if we will run it, we get true and false, which is very not what we expected. In order to figure out why, while debugging, I will make a long story short, because after all, it is only a 20-minute talk. We came up using AST, which is the abstract syntax tree. It's a built-in library within Python that helps us visualize Python code the way the interpreter visualizes Python code. So essentially, it's the way the interpreter sees the code, and it helps us look at the interpreter within the same way. So what we're doing here is we simply parse that problematic line of code, we dump it, and then we print it. The indent for is just so we get a pretty print with indentation and all sorts of fine stuff. So I know the output is a bit big, but we're going to go through it line by line, and it's going to make sense, I promise. So what we have here is we have an expression, which is not a surprise. We had a Python line, which is by default an expression. But that expression is a tuple, which is the first problem we see. We expected it to be a comparison. We expected it to be something compared to something, which is not. It is a tuple. ELTS, it's the elements. And the first element within that specific tuple is a true constant value, which is surprising, to say the least. And after that is the compare. So that makes a little bit of sense. So by seeing the compare as the second element in the tuple, we might figure out that Python code actually looks at that line of code as if it was written like so, with parentheses around this part. And by doing that, it makes sense. Python simply didn't view that line of code the way I wanted to view the line of code. At that moment, I wanted to migrate to JavaScript, specifically. But with that aside, what does it have to do with match case? What am I speaking about? What the hell is going on here? So this mistake was so bad, and it inherited on a such crooked pattern that I simply wanted to erase it from the entire code base. I wanted to spare my teammates from ever doing that sort of mistake ever again, and the best way to do it is by implementing custom linting rules. Those of you who saw the talk earlier in this room about custom linting plugins, you already know how useful that can be. So I wanted to implement it as a custom linting. So what are we looking within the rule? What actually, if we boil it down, what is actually the problem? So we're looking for a comparison, but as we see in the AST, comparison consists of a few parts. We have a left, which is the left hand of the equation. We have the ups, which is the equator itself. In this case, it's an equal, but might as well be a not equal, a greater than, or a lower than. We don't care. It's an equator of sorts. And we have the comparators, which are the right-hand side of that equation. In this case, the problematic pattern is we're looking for a const with some sort of equation to a tuple. And any sane mind would say, you cannot compare a const value to a tuple and expect it not to be false in Python. So that is the pattern we're looking at. And just happens to be, I implemented it with the Flake8 custom plugin. So it's a huge, disgusting chunk of code with a lot of ifs, like it's a very, very iffy code. It's very complex to maintain, to debug, to extend, basically it's a disaster waiting to happen. So after seeing that, I wanted to make it better. Lo and behold, Python 3.10 just released. Bells and whistles around, they have match case. How does that helpful? Well, a lot of you who came into this talk might have thought, well, match case, what there's to talk about? It's just another switch case for Python. A lot of people think it's controversial, it's an anti-pattern, it's not very well designed for Python, it's not very Python-like to use switch cases in Python. Not to say you're wrong. You could use match case specifically to cater for the cases of a switch case. It can be one-to-one mapping to a switch case. But in my opinion, it's redundant because the if-else looks almost identical. It's less indented, and in the match case, you don't even get performance benefits that you would get in switch case. Like you don't have the jump tables or the switch dictionaries, basically, because match case evaluates any case against the match argument. So with that in mind, why would you use match case, essentially? So as in Python, there's more to it. They wouldn't implement a feature like so many years into the runtime of the language just to stay on par with languages like Java. So the actual use is in the name. Match case in the documentation is referred to as structural pattern matching, which in itself says a lot. It is designed to match complex patterns easily. And the way, when I first pitched that talk to people in my company, like as a rehearsal, one of them was like, it's regex for objects. And I was like, yeah, that's true. It's like regex for objects. It's very, very good way to think about it that way. So wouldn't you know it, within the previous example, we are trying to find a complex pattern within a complex data set. Complex data set being the abstract syntax tree, which is my entire code base. And the complex pattern is a const value equal to a tuple, which will never end well for us. So we want to find that specific pattern in that specific data set, which is my code. So let's go about and implement it right now. And hopefully I will not mess this up because I'm live coding this. So for those of you who don't know, I'm going to do that with Flake8 custom plugin. The Flake8 custom plugin. Flake8 is a linting library for Python that is very easily extensible, very easy to implement custom behavior on top of that. So the way you do it, you simply declare the custom plugin with a name and version. You init it with the AST, which is the abstract syntax tree of the code base that you're trying to go over, our data set of sorts. And then we implement a run. We create a custom visitor, which we'll get to in a few moments. And then we need to visit each node of the tree and look for that specific pattern within the AST. After that, we can yield the errors. So by proxy, you know that we are aggregating or getting errors as we go along, and then at the end, we just throw them out completely. So let's build the custom visitor. So we initialize and get the errors array, errors list that we will later yield errors from. And then we want to visit the tuple. We get a node, which is a type of a tuple, and then we start match casing. We're matching against the node. So what we're looking at, essentially what I said before, the pattern is that we're looking for a tuple with the elements. We don't care what is the first element. This is just a fancy way of saying I don't care, but we need at least one. After that, one or more elements in the tuple, I want to see a comparison with the left side of I don't care. The operator is I don't care, and the comparators is another tuple. So something with some sort of ops comparator to another tuple with the elements of, you guessed it, I don't care, but they do exist here. So I need some elements which are not empty. In that case, let's append the error. We append it using our named tuple that we defined a little bit above this specific code. We get the line number, the column offset. We give some awesome descriptive error message. By the way, if you ever to recreate this, Flake8 requires that the message will start with the specific error code that you gave it within the .flake8 file. So it took me many hours of debugging just to add that specific error message for your time's sake. And that is specifically it. With that single case, we described that entire complex pattern that we see before. So let's just take a minute to digest what we actually did. We looked for a case which is something that exists with a comparison to something that is a tuple. It's very human-like. Like it's very easy to describe what admittedly is a complex pattern with very low code. Just a reminder, this was the code before, which is terrible and awful, and this is the code afterward, which is, in my opinion, a lot cleaner, a lot easier to maintain. And if I have use cases that are adjacent to that specific use case, it's very easy to extend. And given enough time, every code will have to extend, so it's probably a good idea. Let's talk a bit about potential use cases. So the first one that we just saw was doing that for finding linting rules. It was very straightforward. By proxy, we're actually finding a pattern within a complex data set, which was the abstract syntax tree. Another potential cool use case is doing that with CLIs, which every code YouTuber's ever had a video about it once it first came out, which is why I decided not to do an interactive CLI, but it's just as easy. You can do validating custom syntax. So funny story, we actually have at Beatsite a component with somewhat of a custom syntax, like our imaginative reducted programming language that we use for some quantification models. And we might want to validate those specific rules with match case. It's perfect for that use case. It's also very good for looking at patterns in complex data. Like if you were in the previous talk where we talked about NumPy arrays, it might be useful for that too, because at the end it's just patterns within a complex set of data. And many more. Like the subject of match case is very controversial because a lot of people thought it will lead to anti-patterns that will stop people from using strategy, from stopping people from doing correct designs. But in my opinion, it's a way to overcharge what is already there, which is Python is mostly used for data. And as such, it needs good tools to handle complex data, complex structures, complex patterns very easily. And this is why Python 3.10 got match case. The key takeaways I want to leave you with today is sometimes Python features are more than they seem. Sometimes you should step aside out of controversy. Like if I were to take it at face value and say, match case is what everybody say it is, it's not special, it's nothing important, and it just as is, I wouldn't have used this. So I encourage you to subvert the expectation of people for stuff to suck, basically. Try to go for yourself and figure out if something is useful for you or not. Structural pattern matching can potentially save lives. As it did before, it saved me from destroying the world. And for the last takeaway, I encourage you to keep up to date with the latest Python features. They continuously ramping up stuff. They have awesome features every day. And Python 3.11 is something that I'm very excited for, being a geared developer. One thing I didn't do at the end is that I didn't show you that we actually, after saving that plugin, let's save it and go to our original code. We will now get a linting error about that specific rule, which if done correctly, like if you use a pre-commit or anything, will essentially block that from getting into the code base ever again. Come say hi after the talk. Thank you. And if there are any questions, please, we have 5 more minutes for a question if someone has a question. Thanks.